Hello, this is the part 2 of the Advanced Learning Unit of the Educational Module IoT Business Value. In this section we will present some case studies of business that use IoT technology successfully. The following topics will be discussed as case studies: smart farming and automotive industry. Modern agriculture can be referred to with many ways. Agritech is one way to be referred and refers to the general application of technology in agriculture. On the other hand, smart agriculture is another way and refers to the IoT solutions in agriculture. In more detail, smart agriculture consists of the collection of food and agriculture production with the use of Internet of Things, big data, and advanced analytics technology. The most common IoT application in smart agriculture are sensor-based systems that are used to monitor any factor influencing the production, such as soil, fields, livestock. Vehicles, drones, autonomous robots and actuators used for smart agriculture. Smart greenhouses or hydroponics that are connected agriculture spaces. Data analytics, visualization, and management systems. Expanding the traditional technology with the use of IoT technology will benefit the industry area applied. Using the IoT technology in smart agriculture, the second one is benefit in the following ways: excelled efficiency, expansion, reduced resources, cleaner process, agility, improved product quality. The process of upgrading the traditional technology into IoT and big data technology cannot be done without any problems. Connectivity: an IoT system needs connectivity to be provided throughout the agriculture environment in order to work. In general, the connectivity creates a problem in IoT solutions due to the diversity of the system using different protocols and data transmission methods. Design and durability: any IoT system used for agriculture needs to be able to handle outdoor space conditions. For this reason, the design of each needed solution must be uncomplicated and functional. Limited resources and time: the constantly changing environment and lack of time are two parameters that need to be considered in the IoT solutions provided in the area of agriculture. Smart farming is an emerging concept of farming management using modern information and communication technologies. The technology used for smart farming include IoT, robotics, drones and AI. These technologies are used in order to increase the quantity and quality of products while optimizing the human labor required by production. The technologies used in smart farming by present-day farmers are the following. Sensing technologies include water, soil, light, humidity, and temperature management. Software applications include specified solutions that target specific farm types. Communication technologies include cellular, LoRa, etc. Positioning technologies include GPS, satellite, etc. Robotics includes autonomous tractors, processing facilities, etc. Data analytics include standalone analytics solutions, data pipelines for downstream solutions, that underlies the decision-making and prediction processes. The IoT-based farming cycle consists of 4 phases: the observation, diagnostics, decisions, and implementation. In the observation phase, the sensors record observational data from the crops, livestock, soil, or atmosphere. In the diagnostics phase, the values of the sensors are fed to a cloud-hosted IoT platform with predefined decision rules and models that ascertain the condition of the examined object and identify any deficiencies or needs. In the decisions phase, after the issues are revealed, the user with the help of the machine learning-driven components of the IoT platform determine whether location-specific treatment is necessary and if so, which. In the implementation phase, the treatment that is selected in the previous phase needs to be performed in order to correct the operation of the machines. After the evaluation phase, the cycle repeats from the beginning. The benefits of using smart farming are the followings: data collected by smart agriculture sensors, better control over the internal processes which results to lower production risks, cost management and waste reduction thanks to the increased control over the production, increased business efficiency through process automation and enhanced product quality and volumes. All of these factors can result in higher revenue. It is believed by many that IoT can add value to all areas of farming, from growing crops to forestry. Here, we present two major areas of agriculture that IoT can revolutionize: precision farming and farming automation/robotization. Precision farming is an IoT-based approach that makes farming more controlled and accurate. In other words, plants and cattle get precisely the treatment they need, which is determined by machines with superhuman accuracy. The biggest difference from the classical approach is that the IoT-based solution allows the decisions to be made per square meter or per plant/animal rather than for a field. With this method, farmers can boost the effectiveness of pesticides and fertilizers or even use them selectively. Smart farming technology enables farmers to better monitor the needs of the animals individually and adjust their nutrition accordingly, while preventing disease and enhancing herd health. Farming automation and robotization can be seen in the following areas: precision livestock farming, automation in smart greenhouses and agricultural drones. Farmers can use wireless IoT application to monitor the location, well-being, and health of their cattle. The farmers can identify sick animals with this information and separated them from the herd in order to prevent spreading the disease. Traditional greenhouses can control the environment parameters through manual intervention or proportional control mechanism. These techniques can result in production loss, energy loss as well as increased labor cost. On the other hand, an IoT-driven smart greenhouse can intelligently monitor and control the climate, as well as eliminating the need for manual intervention. In a smart greenhouse, various sensors are deployed in order to measure the environmental parameters based on the specific requirements of the crop. The data collected are stored in a cloud-based platform for further processing and control. In the agriculture area, it is incorporated for both ground-based and aerial drones in order to crop health assessment, irrigation, crop monitoring, crop spraying, planting, soil and field analysis. The drones can collect multispectral, thermal, and visual imagery while flying. The data collected by the drones provide the farmers with insights in different metrics like canopy cover mapping, field water pond mapping, scouting reports, stockpile measuring, chlorophyll measurement, nitrogen content in wheat, drainage mapping and weed pressure mapping. When referred to automotive industry, all companies and activities are included that are involved in the manufacture of motor vehicles. These companies are involved in the design, development, manufacturing, marketing, and selling of motor vehicles. It is worth mentioning that it includes components deal with engines and bodies and excludes the ones that deal with tires, batteries, and fuel. The main principal products include passenger automobiles and light trucks, such as pickups, vans, and sport utility vehicles. However, commercial vehicles, such as delivery trucks and large transport trucks, are considered secondary priority. The use of IoT technology in the automotive industry not only transforms the automotive industry itself but also the roads. 5 ways are presented that IoT transforms the automotive industry. It will change the way people drive. It can improve road safety. It can help solve traffic congestion in cities. It will lead to better roads. It can help reduce pollution and energy expenditure. IoT technology can be used to change the way people drive. The standard cars could at some point evolve from merely assisting drivers to fully taking control. The integrated cars equipped with sensors will be able to recognize and communicate with upgraded road signs, marking and through a network of cameras. The vehicles could be able to do tasks for drivers as well as pay for their own insurance. The use of IoT technology can be used to detect accidents and bad driving through alerts. The majority of accidents are caused by human errors. With the use of IoT technology, these type of accidents can be reduced by monitoring driving habits and recommendations that can be sent to drivers. While more vehicles become autonomous, the number of accidents will be decreased due to collecting more data in order to improve the driving habits of vehicles on the road. IoT technology can be used for swarm intelligence in traffic. Congestion can be reduced when traffic operators will coordinate cars. IoT devices can identify common choke points as well as the time of day the roads become busiest. Additionally, IoT can help engineers and road experts in developing new plans that can alleviate traffic congestion. Information about city roads can be revealed from IoT data and used to create greener solutions. Investing in road sensors, phased traffic lights and smart parking can help reduce the toxic gas emissions. Unnecessary electricity consumption can be saved by tracking the movement of street lights on a road and determine when the light is needed. IoT technology can be used in building roads that can help detect road maintenance needs, traffic usage and accident statistics. Additionally, it ensures that roads are not left in poor condition for a long period. It is possible that in the future, roads can be turned into energy sources and used for solar energy power in order to power electric vehicles. Automotive industry IoT introduces entirely new layers to the concept of traditional cars. Traditional cars upgrade to connected or smart cars, which become a revolutionary way in driving. IoT has transformed the automotive business in all directions, from vehicles tracking to IoT management. IoT applications open up new opportunities for vehicles in the automotive industry. The following two apps are further explored: vehicle tracking and connected cars. Monitoring the location of each vehicle with the use of a GPS-enabled trackers that communicate with a local low-power wide area network. Vehicle tracking can be used by salespeople to quickly find vehicles. A user interface displays the vehicle location and information. Additionally, vehicle tracking can be also used from consumers in various ways, such as finding the parking location, if it is stolen, or even if their children have taken it out for a ride. To track a vehicle, a GPS-enabled device is plugged into the vehicle's diagnostic port. Connected cars are built from the cooperation of automobile manufacturing companies, telecommunication service providers and software companies. A connected car is a car that is equipped with internet access. This allows the car to share internet access as well as data with other devices that are either inside or outside of the vehicle. Nowadays, only a small number of cars that are internet-enabled exist, but it is expected that the number will rise in less than a decade's time. A connected car includes the following characteristics: sensors, battery life, infrastructure, location services, navigation, maintenance, dashboards, remote control, and zero emission. Connected cars, just like smartphones, will have applications and services to control different useful data collected from the vehicle or the driver. Such applications are going to make the driver's life more easy. The following applications or services are some features that can be developed with the use of IoT technology. Infotainment is an in-vehicle system that delivers a combination of information and entertainment. It is worth to mentioning that infotainment options need to be organized well, and their accessing features should be intuitive in order to avoid drivers to be distracted. Vehicles and smartphones integration can be done with using onboard diagnostics port, which monitors emissions, mileage, speed, and other data, can be displayed to the driver's smartphone. Information about the vehicle, like engine problems or crucial parameters, as well as sent them to service providers for analysis. Driving insight, analytics can be done by using a smartphone's sensors in the vehicle. Data collected from its sensors can be used to model the driving behavior. Onboard diagnostics for predictive maintenance can be done by the onboard diagnostics port, which is used for self-diagnosis and reporting any occurrence of issues that may or have already occurred within the system of the vehicle. Real-time driver monitor is a real-time monitoring system of vehicles that is developed to control the speed and fatigue level of the driver in order to prevent accidents. Geofencing and speed monitoring can be done by using speed sensors to measure the speed of the vehicle. It is possible to alert the driver at times of exceeding the predefined speed threshold, as well as using location tracking sensors, like GPS, to alert the driver if it has gone out of a predefined geographical area. Stolen vehicle tracking is used to track a vehicle that is stolen with the use of IoT technology on the vehicle. Using the GPS and GSM hidden in the vehicle, it is possible to monitor and track the location of it. Biometrics information for driver identification is used to identify and authenticate the driver with biometric information, as well as monitoring the health condition of the driver in order to prevent accidents. The emergence of more connected cars and the in-vehicle embedded connectivity is becoming common. As a result, new vehicle communication arise. In the vehicle communication, three categories exist: the vehicle-to-vehicle, the vehicle-to-infrastructure, and vehicle-to-retail. Vehicle-to-vehicle communication is a wireless network communication between vehicles. Each vehicle broadcasts a message with its speed and location to its nearby vehicles over an ad hoc mesh network in order to prevent accidents. Vehicle-to-infrastructure is a wireless information transmission between vehicle and roadside infrastructure in order to avoid or mitigate accidents, as well as providing a wide range of other safety, mobility, and environmental benefits. Vehicles can communicate with roads, digital signage, traffic lights, safety and control systems in order to avoid crashes and traffic congestion. Vehicle-to-retail is a retail industry communication method, where retail companies present to drivers various location-based advertisements. IoT technology can be also used in order to upgrade the transportation system. Different aspects can be improved in the area of transportation, like parking, traffic, street lights, etc. Some of the most common apps for intelligent transportation are the following. Smart parking is a system that will allow people to reserve a parking space, which optimizes the use of parking space and will result in efficient parking and smoother traffic flow. Smart street lighting is a system where the street lights are dimmed or switched off when no activity is detected, but brightens when movement is detected. Intelligent traffic control is a system that gives priority to selected types of users, like public transport or emergency services. Emissions and air quality monitoring is an IoT-based technology system used for monitoring and controlling vehicle emission. The increasing development of IoT technology in the automotive industry arises the need of new generation of cars. The new generation of cars includes autonomous/self-driving cars and electrical cars. Autonomous/self-driving car is a vehicle that is designed to sense its environment and navigate without any human input. Electric car is a vehicle that is powered by an electric motor using electrical energy stored in an array of rechargeable batteries. This is the end of the advanced learning unit of the module IoT Business Value.